name's Alexis. I'm a mechanical engineering student.
Hey, my name's Alexandra. I'm a civil engineering student.
Hi, my name is Latifa Riley, and I'm a mechanical engineering student.
My name is Elisa Naranjo, and I'm an environmental engineering student. Design criteria. So I'm guessing 1, 2, 3, 4, 5, 6, 7. So I'm guessing the first one is like the design process, which is like this video. Needs to present 3 potential designs that were discussed prior to building anything.
Hope that this isn't full.
Pieces of these designs that were used in the final product should be emphasized. What?
Does it give you like a rubric?
No, this is just like in the thing.
Oh, the criteria. Oh, okay.
Oh, sorry.
Appropriate design criteria must be determined.
We could do something like this. Like if we're gonna do the ping pong one, then we can, okay, this is the bullseye. Then we like pull the thing, and it flies into the, that's obviously like, it flies into the hole. Well, every time we pull it back. We would have, for the spring, we would have to like make it so it extends all the way. Because if we do it partially, it's gonna fly like this way. You know what I mean?
Yeah.
Mm-hmm.
So we'd have to pull like all our fours for this one in order to get to the same thing. Because I mean, there's human error and everything.
For the ping pong thing, we have to apply what we did in class today.
Yeah, but it wasn't that hard though. It didn't take that long.
Yeah, with like the angle and then the length.
And it would be
everything.
kind of cool, like if we were like to present it kind of thing, we can design the whole thing. We can paint it, we can like do whatever we want with it. I mean, the water filter, we just have to calculate the mass of the ping pong ball. I guess in order to like accurately, you know, look at it and stuff.
Yeah, we have to do like angle and this is the distance.
I mean, realistically, it's just like the Pythagorean theorem.
Yeah.
Yeah.
And then there's the
Of course, it would be
figure.
like gravity pulling it down, but that would be like the only factor against it.
Yeah, I mean, if we were to just pull back whatever we're using as hard as we can, like, it's gonna be fine.
Yeah, as long as you use the maximum force available for the spring, that way it's like not uneven. You know what I mean? Like if we pull it like tad
Barely,
bit, yeah, then it would go have a different result. But
I think it's in our best interest to have a very large target.
yeah, you know, it's specify how
Just
big
like
it
make
is.
it super.
Yeah,
Like
different types of springs though, because there's like we just have to get a giant one maybe. Like what we can do if we do the ping pong one, we can like I feel like it'd be a little bit cheaper because we can just use like.
We can get literally like cardboard and make a little like tunnel. And then
Yeah,
just,
or
like,
you can
put
get
some-
PVC pipe
Yeah,
and then just cut it.
but I think you have to get packs of them. So.
Or we can just borrow it from someone.
True, there's definitely people that. Oh, I could probably just ask my roommate. She's always at parties.
Oh my gosh, okay. So we could probably get that for free.
Yeah.
Yeah.
And then we'd have to come up how to stand it, kind of. Okay, so if we're thinking it the way I'm thinking, we have to use a pipe or something that has the ping pong in. And then we have a spring, and then we have something holding it, kind of like that.
Yeah.
But the spring has to like be shot backwards.
Yeah, so you'd have like a pulley right here. So you pull back, and then you let go, and the ball flies.
Yeah.
Yeah, because like, I don't know, like in a pen, like it has the spring that you push in, and then it coils and then it shoots out.
Yeah.
So we'd have to have something that like will keep it coiled.
Yeah, you have to keep it coiled, and then you would pull back the coil as if like, because it's already forcing itself to like, you know, forward. So you pull it back, and then it probably spin. But it would have to be the opposite direction though, because if it's coiled on the top part, like it stopped right here,
Yeah.
then you would have to put it on the opposite side where it pushes forward. You know what I'm talking about? Like the pen when you click it,
Yeah, because
it's like the bottom goes inwards and then it moves downwards, kind of thing. Like it stays fixed in one area.
Yeah, so it's like if the,
design wise, this needs to just be probably like half of this, like the length, just because
Half the way.
I feel like it'll be harder for the ping pong ball not to like be hitting the sides if it's like a really long.
Yeah. So the diameter or the radius would have to be like half the size of the ping pong ball.
Yeah.
Like half time. Okay.
Yeah, and then so like twice the size, and then the length needs to be shorter so it can get out quicker.
Yeah. Okay, so for the ping pong, then we have to have a spring that would be like coiled up, and then it would like kind of do that.
Mm-hmm.
It would have to be like fixed on this side. And then for the pulley, I feel like it wouldn't be that bad. Like if we had like a spring, we could like put something in between it, that way it can pull kind of thing. And we just put like a little thing outside the tube.
Yeah.
Like you just pull this backwards.
Yeah.
And then we would need the stand. We can like put that on anything, to be honest.
Yeah.
We can put it on a table, but I don't know how that works. We can like, either we can put it on its own stand by itself, or we could put it on a table
Mm-hmm.
and have it at like an angle like this, and then put like a little stand right here that would have it at an angle where it has like it can go on any table as long as it's like a certain height, and then the ping pong will obviously like shoot out.
Or it couldn't go on the floor.
It can go on either one or wherever you want, but it'd have to be on an angle. So if we did it on a table or on the floor, we'd have to have something that would hold it up.
Yeah,
at
this
an angle.
definitely can't be flat or it's just gonna like roll across the ground.
Yeah. And then what else would we need for that?
Really, I think that's it.
We need a pulley.
We could literally get like a soda can and just like tape it to the pipe thing and just have that as like the thing to hold it up.
Yeah, that's true. We would have to figure out the angle though,
Yeah, for
Yeah.
sure.
because it says 10 feet, so it'd have to be like that. So it'd have to like fly directly onto the. The way I'm thinking it couldn't be like such a really tall height, because if you're putting so much force into it, it's gonna like fly, like go really high. But if we put it at a low angle, but then we have like a good amount of force onto it, it'll stay low and stuff. So I don't know. There's that one for the ping pong. So what are some pros to this one? It might be cheaper.
Yeah, we definitely wouldn't really have to spend money on anything because we don't have to get.
Yeah.
Yeah. So less heavy.
Yeah, and then I feel like there's less maintenance.
Yeah. Okay.
And the cons are really just like if we screw it up.
The cons is
mathematical errors.
Like,
mathematical errors. Yeah.
Yeah, I feel like it would be like a lot of like
Guesswork.
calculating things to like very small angles and stuff.
Yeah.
Okay, mathematical errors and then maybe human errors.
Yeah.
I mean, that could be like the only thing, because if we get the math right, it'll obviously land where we want it to land. And we would, I feel like if we did it, we have to do it indoors, because if we do it outdoors, it's air resistance and stuff,
Yeah.
and that would like impact it.